All right, in this video, I want to specifically talk about the heat of fusion and the heat of vaporization. And just to be clear where those are, if we had a curve that had temperature in degrees Celsius on the y-axis and then heat added along the x-axis, those two portions are the flat portions of this curve. When I'm trying to turn something from a solid to a liquid, there's no temperature change. So to calculate the amount of heat that needs to be added to do that, we use an equation, Q equals mass times the heat of fusion. So that specific term right there, that is also known as the latent heat because it's really hidden heat. It's all going into that phase change. So you can't use Q equals MC delta T when you're at a phase change portion. And this is for water. We assume the freezing point and melting point are 0 degrees Celsius. Up here is the phase change from a liquid to a gas. So again, it's a flat portion of the curve. All of the energy is going into the phase change. So you use Q equals M, mass, times the heat of vaporization. And sometimes it's referred to as latent heat as well, because all of that heat is going into that phase change. So when you need to calculate the heat that you need for a phase change, you use these two equations. And I want to show you some simple diagrams to explain exactly what that means. If you had a beaker of water, and let's say we actually start out with ice, and I want to turn that to water. So I want to melt the solid into a liquid. I want to go from here to here. Well, what do you need to do? You need to add heat. So you can put it on a hot plate, you can put it under a burner, whatever you'd like. Either way, you need to add heat to the ice in order to get it to melt. So we're going from a solid to a liquid, and that's melting. And because I'm adding heat, it's endothermic. The direction of the heat flow is into the system. And we call that the heat of fusion for water. And that number is specifically 334 joules per gram. What that means is if I have 1 gram of ice and I want to turn it into liquid water, I need to add 334 joules of energy. So there's some questions that ask you about what is Q, what is the heat if you want to turn 2 grams of ice into liquid water. You would just take 2 grams times your 334 joules per gram, and you would get 688 joules. This number can also be reported in kilojoules per gram or calories per gram or even joules per mole. So as long as it's energy over mass, and it could be energy over moles, that number could look different. But for water, it's always 334 joules per gram. If we want to take that liquid water and we want to vaporize it, we also need to add heat. So here, the heat flow would be going into the system. And then this would mean I would be going from liquid to gas. And I'm vaporizing the water. And again, it's endothermic because the heat is flowing into the system. And we call that the heat of vaporization. The heat of vaporization for water is relatively high. It is 2260 joules per gram. So what does that mean? If I had 1 gram of liquid water and I wanted to vaporize it, the amount of energy I would need to do that would be 2,260 grams. So when you calculate Q for the heat of vaporization, you need to use this equation. And in a phase change, that's solid to liquid or liquid to gas, your Q is always positive. Now let's look at the reverse of this scenario. So let me erase this. And let's pretend we're going in the reverse direction. So if I want to go from a gas to a liquid, and then from a liquid to a solid, in order to do that, I need to remove heat. So the heat needs to be coming out of the system. So when I go from a gas to a liquid, I'm condensing. And condensing is exothermic. My Q is negative. The heat is traveling out of the system. So from a gas to a liquid, we use that same term, the heat of vaporization, but it's the negative of the heat of vaporization. So that was 2260, but we need to make it negative 2260 joules per gram. And in the readings, it actually calls that the heat of condensation, because it's a little bit more appropriate, because we're not vaporizing, we're really doing the reverse. So if you want to call it the heat of condensation, that's fine too. But either way, you need to know that that value is negative because heat is coming out of the system. Now, if we want to go from a liquid to a solid, same thing. You need to remove heat. And that's what your freezer does. So if I want to go from a liquid to a solid, I'm freezing. And since heat is being removed, that too is exothermic. So my Q will be negative. And that was that same heat of fusion. And that number was 334 joules per gram. But you need to make it negative, and sometimes it's called the heat of solidification. Or you can just write heat of solid, and it's negative 334 joules per gram. So the equations that you need to use to calculate the heat for phase change, you're going to have to use Q equals M times the heat of fusion, or you might have to use Q equals M times the heat of vaporization. Again, these terms are normally positive. The solidification and condensation terms are negative. And that does it for heat of fusion and heat of vaporization.